In this question, we're asked to find the integral of 3 over the square root of x minus 6x to the power of 4/3. First thing that we need to do in this question before we try to integrate it is, of course, all terms must be written in index form. So our reciprocal here, that also contains a root, must be written in index form. Remember, at this stage we should only rewrite the integral. We shouldn't be doing any sort of integration, although this term is ready to integrate. Square root of x means we're going to have x to the power of a half on the denominator here, and because it's a denominator it means it's a negative term, so we're actually integrating 3x to the minus a half minus 6x to the 4 over 3, and we're integrating this with respect to x. So raising the power by 1, so we get 3x, add the denominator to the numerator, it gives me positive a half, so divide by my new power, which is a half, minus 6x, raise the power by 1, so add the denominator to the numerator, so I get 7 over 3, and divide by my new power, which is 7 over 3, plus c. And this can be tidied up to give 6x to the half, minus 18 over 7, so flipping the fractions upside down and multiplying the coefficient, 7x to the power of 7 over 3 plus c. Okay, let's quickly look at how the marks are awarded in this question before moving on to part B. One standalone mark for the first term, one standalone mark for the second term. There is -1 mark if you've forgotten to do the constant of integration. Okay, let's look at part B then. Part B says the diagram shows a sketch of the curve y equals 6 minus 5x minus x squared and the line y equals 4x. The curve and the line intersect at the point A in the first quadrant, and the curve intersects the x-axis at the points 1, 0 and 6, 0. Showing the working, find the x-coordinates of A. So we're looking to find points of intersection on this curve. That means I'm going to solve these equations simultaneously. So I'm going to say 4x is equal to 6 plus 5x minus x squared. It's a nice version of simultaneous equations because it's y equal to both of them. I can just put each of the functions in x equal to each other. I'm going to add x squared to both sides to get positive x squared. I'm going to subtract 5x from both sides, and I'll subtract 6 from both sides, so that we get left with x squared minus x minus 6 is equal to 0. This we can factorise. Factors of minus 6 that have a difference of -1 are x minus 3 and x plus 2 equal to 0. So this leads to the fact that x is equal to 3, or x is equal to -2. There are two solutions here. But please remember, it says in the question point A is in the first quadrant. That means here we have, if I divide this up now, this is a positive x value, so this is the value x equals 3. So just emphasize that that is the value of x equals 3. It has also only asked for the x coordinate, so we don't need to go back and find the y coordinate. So that was part I. Part 2 says find the shaded area, or find the area of the shaded region. So to find the area of the shaded region, I can integrate between -1 and 3, the upper curve, so y equals 6 plus 5x minus x squared, and then I can just take away this triangle here, which we can find in a moment. Or we can take away the integral. So I'm going to start off by integrating between -1 and 3, the function 6 plus 5x minus x squared with respect to x. So integrating 6, I get 6x. Integrating 5x, we get 5x squared divided by 2. Integrating x squared, I get minus x cubed over 3. So this is between -1 and 3. Now show, and I'm just going to go into the next line so I can show it in one full step. Show the substitution in full. So I get 6 times 3 plus 5 over 2 times 3 squared minus 3 cubed over 3. Take away 6 lots of minus 1 plus 5 over 2, so minus 1 squared minus minus 1 cubed over 3. Once you've shown the integration and once you've shown the substitution, there's no need to do any further work, and this can be typed into your calculator carefully and evaluated. So when you do so, what you'll find is you get an answer of 104 over 3. And you can just leave it like that for an exact answer, and there's no need for a mixed answer either, mixed number answer. So in other words, 34 over 34 and 2/3, I think it is. So now what we want to do is we want to remove this triangle. There's a couple of ways we can do it. We can find the point A and find that as a triangle. So the point A, if we had y equals 4x, so it's on the line y equals 4x, so y equals 4 times 3, which equals 12, so this is the point 3, 12. So as a triangle, I now know that the base is 3 and the height is 12. So the area of the triangle, which is a little bit quicker than doing the integration, the triangle area is a half times the base, which is 3, times the height, which is 12. So we get half of 36, which is 18. So finally, the shaded area equals 104 over 3, take away 18, which gives an answer of 50 over 3. Okay then, so let's have a look to see how the marks are awarded in this question. Initially, there's a method mark for the use of simultaneous equations to solve and find the x coordinate. There is then a method mark for trying to attempt to solve the quadratic, and there is an answer mark for getting that x is equal to 3 and highlighting the fact that the coordinate we are after is x equals 3. Part 2. There is a standalone mark here for demonstrating the correct integration. There is a standalone mark here if you have demonstrated the correct substitution. Remember, don't evaluate anything in the substitution stage. And then there is working through a method mark for doing the area of a triangle, or alternatively integrating. There's a method mark for subtracting the two areas, and finally an answer mark if we got to 50 over 3. Okay, well, I hope that all made sense and that you was able to follow my working out, and also that you was able to understand how to mark that question.